Okay, so today what we're going to do is lesson 4b, defining an arithmetic sequence by recursion. Now, so any sequence is an arithmetic sequence or arithmetic sequence if the rule is to add or subtract. Now, technically, you're only adding, but you're subtracting if you're adding a negative. So we typically like to think of that as subtract, but adding a negative or subtracting a number means the same thing. So, most of the difficulty in dealing with these things is understanding the terminology. So we're going to look at some general notation before we do any math. Okay? And what that means is we're going to use letters in place of numbers. Now, first of all, if you have a sequence, the numbers in the sequence are called terms. And each term can be defined by using a subscript. In other words, a little number at the bottom of a letter. So let's just take a look at that. So say what happens, for example, 1, 2, 3, 4, ... goes on forever. So the first term here is 1. So the first term is 1. So I could say, instead of saying the first term, I could just call that t. And since it's the first one, we call it t sub 1. So this is read as t sub 1, which just is another way of saying, of writing the first term. But clearly that's a lot faster and easier than to write first term. Okay? Now, if you want the next one, you're just adding to that first one. So the second one, so if this was the first one, then the second one is going to be t to the 1 plus 1, or t to the second. And again, that simply means the second number. And we could keep on doing that no matter how many terms you have. So 2 plus 1 would be t to the third, or the third term. So for any term, we could write t to the n plus 1. So all we need to do here, so if it's a fourth term, that would be 3 plus 1. If it's a fifth term, it would be 4 plus 1. So you'll see this notation to represent any number in the sequence. Now, we're also going to be talking a little bit about what's called the common difference. And that's how you know that something is an arithmetic term, is because you're going to have a common difference. And then the symbol for common difference is D. Now, the first term also has a specific letter that we use. If it's the first term, we usually call it T1, but we can also call it A. And the reason they use A is simply because A is the first letter of the alphabet, and this is the first term. So, T1 is also known as A. And you're going to see where all that comes together in just a moment. So the first thing we want to do is talk about a common difference. To find the common difference, all you're really looking for is a change. And anytime you're looking for a change in mathematics, you simply take the new value minus the old value. So for us, that would be, for example, term 2 minus term 1. And we need more than 1 to confirm that there is an actual common difference. So then we would take term 3 minus term 2, and you could test it again by doing term 4 minus term 3, although 2 is plenty usually to be able to establish a pattern. But you do have to be careful, because sometimes they'll throw in some that it seems to be working, but it isn't. Again, remember, it's always the newest one, so term 2 minus term 1, otherwise you're going to get the wrong sign. Okay? Once you know the common difference, then we can determine a rule for finding any value in that sequence. So to find the sequence, what we'll do first is find the common difference. And if you remember, the common difference we call D. Second, simply add that common difference to the first term, which of course your book is going to call T1 or A, same thing. And then you're simply going to continue to create your list of numbers. Okay? Now, each one of those, again, can be defined as a t value, some t to t some something. So the second one is T2, T3, T4, etc. All right? So we can therefore say that t to the 1 is A, your first value, and any t to the n plus 1 is simply equal to t to the n plus d, where d is again the common difference. And so it's this type of notation that gives you trouble, but it's really not that big of a deal. All right? So if you're looking for the fifth number, then t to the fifth plus d. All right, t to the 1 plus d probably, and you're always going to start with the original 1. So any other value can be found by adding the first value and the common or the previous value and the common difference. So this one, think of as any value. This one, think of as the previous one. And of course, d is the common difference. Right? Now that works for any number as long as n is bigger than 0, because if you have 0, that means you don't have a number. Okay? All right. And then we're going to talk about graphing these, but once you have a chart of values, you've plotted those on plotted points before, so that should not be any big deal. Now once you've found a pattern, or you're using a pattern, by finding the common difference and plotting things, we need to talk a little bit about the graphs. If you plot these, and the dots make a straight line, then they are called collinear, sharing the same line. Okay? And if D is positive, then what you have is linear growth. So in other words, as you go, the numbers keep getting bigger and bigger. But if D is negative, we have what was called linear decay. And so it keeps going down further and further and further. In other words, the numbers get smaller as you go. The common difference is causing it to decay, to get smaller. You're going to see how these are used in some patterns and some sequences later. Now, the larger d is, and we're talking about absolute value, so without the sign, the faster the change. And we're going to look at ways in which you can use all of this information to be able to describe what's happening to a graph.